Al, thank you much for joining us on Curtain Wall Conversations. This is a conversation we've been definitely looking forward to. You and I have known each other for a number of years now, and I was hoping to start off with a question regarding your very maybe enigmatic or sort of unusual career path and how it is that you got to be where you are today at Fenestration Canada. If I understand correctly, you started at McGill.
Aspired to study art, and my father was very much opposed to it. Let's just say we had our differences, and I spent a few years outside of the home until we resolved those differences. I ended up going to art school for a year, but unfortunately it was the 1970s. There was a kind of a revolutionary spirit at the Ontario College of Art, and I didn't learn a sweet thing in that whole year. It was all conceptual art and radical things and throw away the past and think of the future, and I really wish I would have learned color theory and some useful skills, but I must say that I did not learn much of value in that year at Ontario College of Art. So I came back home and went back to take some science courses so I could get into the architecture faculty at McGill, and got my Bachelor of Science in Architecture. I finished my studies there in '77, and at that time in Quebec, the Parti Québécois had just been elected, and it had the unfortunate effect of causing business to kind of clog up. Many English Canadian owned businesses, national business across Canada and international businesses were concerned. What was this province going to do? Are they going to separate? What's that going to do for our business? So a lot of head offices were starting to move to Ontario, and there were no construction jobs in Montreal. The tower cranes were all just hanging in the sky. And, there you are, you're finishing your studies in the spring, and there's no jobs to be had in your field. And I run across some people and they say, "You found a job yet?" And they said, "No." Call Eddie Makauskas in Calgary. I hear they're hiring. And my family, we're from the Lithuanian Canadian community. My parents are both from Lithuania. And so I kept running across people in our community telling me, "Well, call Eddie Makauskas." And I didn't even know the guy, but he had studied in McGill before me. When I finally called him, he hired me over the phone and I had a job. And I started working for ATCO. They had opened up a new division called ATCO International, and their plan was to consolidate engineering teams in Montreal, Waco, Texas, and Riverside, California, in Calgary, and manage the international work from there. So I worked there for a couple of years until they closed down the international division, because I guess in the end it wasn't working out as well as they'd planned. And after that, one of the project managers I'd worked for at ATCO had started another business, and he also was working for Oxford Development Group. And one day he and I met on a plane, and he asked what I was doing. I was working in another department at ATCO, and he basically said, "Well, listen, you want to work for me?" And the next thing you know, I'm working for Oxford Development Group, one of Canada's premier developers. And I'm working on Eau Claire Estates, which at the time was the most luxurious condo development in Calgary. The architects were Skidmore, Owings and Merrill from New York. And there I was, the guy on site, the site representative of Oxford on that project. And that was going along swimmingly well until the 1981 national energy crisis. The oil industry went into difficulties, a real slowdown of the economy. And essentially, Oxford started cutting staff. And I was the lowest guy on the totem pole. I was the most recent hire there in Calgary. And so I was the first guy I let go. So at that point, another turn in the career trajectory. We had been attending a kind of a charismatic Pentecostal church, and an opportunity opened up to work for the church. And so for the next 4.5 years, I was a lay pastor and in that environment. And the interesting thing there was that while being in that role, I discovered I was pretty good at public speaking. I discovered that while I was talking and explaining something to people, new insights were coming into my mind as I spoke. And things that I had read and thought about, all of a sudden they just coagulated in my mind. And while I'm speaking, I'm listening to myself and I'm learning things. So that was an interesting discovery. Eventually, I thought that I would explore the possibility of studying theology and considering that as a career. We ended up moving from Calgary to Vancouver, and I studied theology at a Regent College, which was a very well respected, you might call it evangelical Christian college on the campus of the University of British Columbia. And I studied there for a year, and that was an interesting experience. I really dove into it. I took 2 years of New Testament Greek, and 1 year I delved into the theology and other courses, biblical studies, and all was going well until the course ended. My plan was to continue studying, but somehow at that point, something strange happened. I had gone to Regent College thinking that what I learned there would provide a grounding that supported everything I believed until that point. Instead, what happened, I found that everything I had learned caused me to question what I believed. And I found that I could no longer confidently believe in the evangelical Christian message, because I realized that what we were believing in 1980s was different from what people were believing in the 50s, was different from what they were believing in the 20s, the 1800s, the 17s, the Reformation, the 1200s, the early church, and the time of Jesus. It was never the same thing. It's been constantly changing and evolving. One of the most celebrated theologians of the evangelical world was one of my profs in that course, and his presentation of how he came to why he believed what he believed was completely unpersuasive to me. And over the next year, I somehow deconstructed everything I had learned and believed till that point. It was kind of a life crisis because, my wife and I were not on the same plane, and you've got a young family, and here you are, you need to find a job. You thought you had started on a new career path, and all of a sudden you realize this isn't really what I want. It's not going to work. What do I do now? So I got a summer job drafting at Columbia Manufacturing, which they did commercial and residential skylights. Basically, it was like this. You're in charge of the project from go to woe. And that was a pretty challenging environment. That was talk about having to learn fast on the job, because you're doing these things for the first time. Unfortunately, though, I ended up with a project where all the big decisions had been made by my boss, and they weren't good decisions because they didn't leave me any room to maneuver or negotiate. Let's just say the project didn't go as well as planned. It was not a disaster. It was a very complicated project, a very interesting project. Perhaps it wasn't as successful as it could have been if I'd had more experience or, more assistance in the role. Company of self-made people. Basically, that's just how they operated. I went to work for another firm in that industry. At this point, I realized, project management is not my specialty. I really don't enjoy working with general contractors. And I don't like that side of the construction industry. Design, beautiful. Design products, beautiful. Manufacture them, no problem. Deliver them to site and get them installed on a commercial project, that's a whole different thing. And I wasn't cut out for that, but I was good at talking, explaining, understanding, and I was good at writing things too. And so I thought, I'm at a crossroads. I don't want to keep doing what I'm doing. I've got a family to support. I can't go back to school. I can't just, not be earning income. How can I transition from what I'm doing to where I'd like to go, but I'm not even sure where I go next? And I came across a book that was popular in the late 70s and into the 80s that was called What Color Is My Parachute? It's kind of it sounds like a hippie book. And it was kind of marketed and presented that way, right? You got to jump out of the plane, what are you going to do? But what was really neat about the book is that it was designed to help you to identify your inborn talents and your skills, the skills you were born with. The author made a big distinction between, don't think of your skills as what you learned at school. Your skills are your innate talents. It's the things you're good at. It's the things that come so easily to you. You don't even think you have a talent. Right. You think it's the stuff you work hard at that you're good at, but actually your talents are the things that you just come naturally to you. Maybe you're a good talker and you persuade people and you're just natural in sales and it just comes easy to you. It's like, hey, it's, you don't have to try. It just works, right? Maybe you're an athlete and you're just amazing. Anything you do, skiing, football, running, whatever, it just comes naturally and you're skillful, Maybe you're super creative and you're always, designing and imagining new things. You're coming up with stories and you can entertain people for hours with the things you make up. Those are your talents. Those are your gifts. And the stuff you learned at school may just be stuff somebody else wanted you to learn. Maybe you studied engineering because your father wanted you to be an engineer, or medicine because your parents insisted you had to be a doctor, So basically the book said, it had exercises and stories, but the exercises, there were mind exercises and other things to help you identify. Think about where you felt the most fulfilled. Think about the things that come naturally to you. Think about things people have complimented you on. Imagine yourself at a party and there's all kinds of people there. There's engineers, architects, teachers, doctors, aid workers, businessmen, tycoons. Which group would you want to hang out with in that party? Like if you're going around with a cocktail, who would you want to talk to? Would you want to talk to the artists, the businessmen, the doctors, And with those kinds of things, these mind exercises, the idea was to help you identify that. And he made a big distinction between what you learned and what just comes naturally and where your true desires are. And sometimes our true desires have been snuffed out by our upbringing. So people have told us, you need to go here, you should be there. It's shameful to think of this career. You got to think of the family reputation. You need to be going that way, not this way. There's all kinds of other things. And when you're faced with those outer pressures, a lot of people don't know what they want. They say, well, I don't know what I want to do. And the reason they don't know is because the thing they did want to do was snuffed out. They were told it wasn't the right thing. It should be something else. And if you are following a path where you're doing what somebody else wanted you to do, but your heart's not in it, you will never succeed. But if you can find what is in you, and what you like to do. And it could be that they want you to be a brain surgeon, they want you to be an engineer, but you just want to work with your hands. You like making stuff. Identify what that is, and then look for opportunities to make a living at it. And that was the beauty of this book, is that it gave you the hope that if you can identify those skills, then the things you do in that direction will be better than what other people do. Once you've identified those skills, think about where you want to use them. Do you want to work for a big company or a small company? Do you want to be self-employed? Do you want to lead people, or do you want to just find your quiet niche? So think about where you want to use those skills, in what environment, with what kind of people. Once you discover that, once you can nail that down in a fairly clear way, you are now in a really good position to sell yourself to someone else, because you actually have skills and interest in an area, and you've already demonstrated probably in your life competencies in those directions. And now you can more confidently begin to pursue that. I discovered that in this process, there are two things I wanted to do. I wanted to write, and I was good at talking. And I also liked photography. And I thought I really liked doing photography. You see this picture behind me, right? And so how can I make a living at this? I started looking at courses offered by school boards, look at careers, what careers in writing magazine articles, this, that. And, I thought, well, writing magazine articles it takes a lot of creativity, very challenging. They only pay you by the word and only after it's published. And that's kind of sounds like a hard way to make a living if you're supporting a family, because what's your steady income going to be? I looked at other, various other options. And then I heard about something called technical writing. And technical writing is where a company hires you and pays you to write stuff. You got a job. You got an income, you got a paycheck, So I looked into it, and there was one course offered at Simon Fraser Harbor Center, downtown Vancouver at the time. It was like a 12-week course, in technical writing. And the instructor was basically teaching the course so he could find more people that he could hire on his projects, right? Because he had a technical writing company. Anyway, it was great. I took the course. I said, I can do this. To me, it was not hard. I look at the syllabus, I look at the examples, and it's like, I can do this. I've been doing this already. So I basically started looking for how to make a living in writing. At this point, I'm still working for a glazing contracting company. The Glazing Contractors Association has decided they want to get a manual written for the association. They need a technical manual. And at that point, the Roofers Association had a technical manual, and it was doing them a lot of good. The Painters Association had a technical manual, and all the architects and the whole North American industry is following the painters manual. We need a glazing manual. And they were about to hire a spec writer to do it. And I'm at one of these meetings where they're talking in public about, yes, we're going to be hiring this specification writer to write our manual. And I thought, man, how can I get in on that project? Because I've been working in that industry now for about 5 or 7 or more years. And I knew all the complaints. The spec writers don't understand the industry. They ask for things they shouldn't ask for. They give us onerous conditions. They don't answer the questions we want, and they give us information that's obsolete. And I thought, I can help this guy do a better job. So I wrote a letter to the spec writer offering to help him, to work with him, because I figured I could contribute the industry's point of view and help him to be more successful. He takes that letter to the Glazing Contractors Association executives, and he says, who is this guy? I got this letter from him. They look at my letter, and they know me because I actually was working for the president at the time. And he said, oh, Al's interested in this. So they fired the spec writer and gave the contract to me. And so I spent the next couple of years freelancing, drafting, working from home, which I loved, and working and researching this manual. And, a couple of years later, the first edition of the manual was published. And I was now on a different career path. I was self-employed. I had drafting work, but I was also looking for more creative writing work. I started doing product catalogs for people, writing their catalog content, writing technical material, writing installation instructions, getting them illustrated. And I realized I'm doing technical writing in the window industry as a self-employed person, and leveraging my contacts in the industry who know me and trust me and like my work, and started going off in that direction. Eventually, one of the clients I worked for had new ownership, and they decided to change how things were done. And at that point, one of the companies just gave me more and more work until I was just working for one customer. So guys, if you're ever freelancing, that's a risky place to be, because even though the people that hired me loved me, gave me a ton of work, and I was happy with it, and they were happy with me, the new owner didn't like this arrangement and changed it. And next thing you know, I'm out of work. Having this technical writing experience, I got a job in the software industry and the computer industry, writing hardware manuals. Later, I got a job with a Vancouver-based software company called ACL that specialized in audit software, and started working there. And within less than a year, I've ended up as the manager of a small department. And I worked at that for a few years. And honestly, that was one of my happiest jobs. I actually had a corner office. I had a staff of 4 or 5 writers. We were handling documentation in multiple languages and, writing white papers and things like that, which was quite interesting. But we reached a point where my dad was getting old. He needed someone to help take care of him. I needed more flexibility. The company wasn't flexible at that point with work arrangements like that. And I realized I need to change. And I'd been doing some freelance work for one of the window companies that I'd had as a client, designing some parts for them and doing some writing. And they'd open up a new company. And basically I called them up and they were happy to take me back. And so this was now in probably 2004 that I'm back in the window industry. The company was Inotech Windows, and I was with them for 8 years and did some of the most interesting work in my career there. They were doing a lot of work in the United States. And in the United States, you really have to be careful to follow all these AMA standards and AMA specifications. That organization is now called FGIA. It used to be the American Architectural Manufacturers Association. And they'd have meetings 3 times a year. And the company I worked for had a problem with one of their specifications. It was causing our European profiles to be failed on a property that they were actually it was good at, but the test method wasn't appropriate. And so my job was to try and get that specification changed. And this was the most interesting assignment because you got to get down there, you got to learn how things work, you got to join committees, you got to play ball to get along with people, help them with their projects, see if they'll help you with yours. And trying to understand the specifications, traveling to Germany, getting data from our suppliers, traveling to the States, talking to people, at these AMA meetings, working on the specification. And lo and behold, 3 years later, the specification was amended and it solved the problem. And, I ended up as a respected, colleague with other people that I worked with at AMA at the time. And at that point, we were also developing impact products for the Florida coast. So I was testing products in Canada. I was testing products in the States, doing impact testing in Florida, trying to get, our product lines qualified for the Florida market. And what do you know, but in 2008, the economy hits another bump. There's a real slowdown at that point. The American economy was slow, ours was slow. And the company decided to abandon that project. And so, we focused more on the Canadian market. But it was a great ride being involved at AMA. And that's where I got experience with the standards writing process, how the standards are developed, and understood how it worked and got to really know the standards at a higher level than I had prior to that involvement with AMA. So, as you can see, the experience is building, right? Glazing system specifications manual, all kinds of writing work for companies, lobbying, trying to get stuff done, at the standards level. So I continued with Inotech till 2012, and at that point, I was involved with the Window and Door Manufacturers Association of BC. Someone had encouraged me to join their board a few years earlier, and at the Fenestration Association of BC. Well, at that time, it was just, Window and Door Manufacturers Association, WDMA. we had started working on a guide for correctly replacing windows, right, in the residential window market. The way it was being done was not good, and there was no good documentation on how it should be done. We ended up having some people from RDH volunteering to work on our committee. Then RDH said, this is really important. We can probably get funding from the Homeowner Protection Office, HPO, which is now BC Housing. They got funding, and it turned into a project where WDMA were the industry stakeholders. RDH were bringing the engineering and building science perspective to this project. And while working on that, I came up with another idea. The energy rating had been a real concern in British Columbia. High solar heat gain windows were considered to be problematic here to a degree that wasn't appreciated as much in the rest of the country, but it was here. I pitched the idea to RDH. I said, we should get a study on this to study the energy rating in British Columbia, because there haven't been any studies for about 20 years. It's time to have a second look at this. Is it still relevant? And I ended up, pitching the idea and co-writing the proposal with the president of RDH at that time, Dave Ricketts, and we got the contract. So here I am, I'm still working at Initech. I'm involved with WDMA, but I've got 2 projects underway with RDH. And one day in a meeting, they've complimented something I'd said. The idea came to my mind, you'll never have a better opportunity to ask this man for a job. Which I did. 4 to 6 months later, I started working at RDH. And at RDH was a great experience. Again, I had brought a lot of experience to RDH from my background in the industry. And then I learned so much more at RDH. And it was my experience at RDH that really gave me the opportunity to do things like the combustible windows code change. There's a project I know you wanted to talk about today. But basically, because you'd expressed an interest in career trajectories and sort of non-linear career trajectories, I'm hoping my story will encourage people who feel sort of trapped where they are. It's not exactly a good fit to where they want to be, but maybe there's things they still like about where they're at, but there's things that aren't working. And what do you do? Where do you go? What's your next step? And I really think that if you can get a hold of that book, What Color is Your Parachute? It's something that will help you. I think it's still available. You can find it as a PDF online, probably for free. It might sound dated, but it was phenomenal advice. And interestingly enough, I did not know this at the time. Years later, after I'd read the book, I learned that the author was actually a Christian minister. I forget which church it was. It might have been Presbyterian or something like that. He was an American guy. And he said that, I wrote the book to a secular audience because I wanted people to know how to find their calling in life. That was so profound because that's what I found. I found my calling in life. Communicating technical information was my talent. Right? Being able to write about it and talk about it was my secret weapon. I didn't learn that at school. I was always good with words. I thought back when I was in grade school, I scored in something like the 98th percentile in verbal skills, but I was totally uninterested in other subjects like math and things. And so, I never did well in school in my elementary years and in high school, nothing exceptional because I was studying things that really weren't what I was good at. Whether you think of it as your calling in life or whether you just think of it as where do I fit? Right? What have I got that works for me and works for others? And how can I make it work? And that book was really instrumental. And I'm hoping that telling you this story could encourage other people not to give up, but to see life as a journey. There may be more ways forward than you can imagine once you start exploring that.
I love that. Love that journey, Al. And all of the moments where, you sort of paused and looked around and saw what your opportunities were. And maybe that's another one of your skills, that you were able to sort of, open your eyes, I think, to the opportunities that were around you. Many of us have this ability to see what's around us, and some of us don't. And I think, it does as well to sort of be encouraged by these kinds of stories and sort of maybe find people in our lives who can help us see sort of what the landscape is when we can't always see it. My own story, which maybe we'll save for another podcast episode, I was also pretty circuitous, trying to go for medicine, ended up selling cars, then ended up in public health, and now we're here in a curtain wall manufacturing role. One of my favorite sayings in golf, and I grew up playing a bit of golf, was that there's no picture on the scorecard. There's many ways to get from A to B. You can sort of go in you can go in the bush, you can go in the water, you can go in the sand, you can all find your way to, the green and in the hole in 4 shots. There's many ways to get from A to B. And I think I love your sort of message that it's very much about the journey.
Very much about the journey. And even the stuff you learned on the wrong path, you might say,
yes,
comes in really handy as you find your right path. And even though
Absolutely.
the architecture, I never worked in an architect's office,
Mm.
and the only things I've designed are home renovations and extrusions for window systems, right? The experience of understanding the architect's world has been invaluable in things like writing the glazing system specifications manual. And even at RDH, working with architects and engineers, it gave me a comfort level in that environment that I wouldn't have had if I didn't have any background at all. This is the thing. On your journey, you acquire skills and credentials and things that can all be part of the toolkit that will
That's
help
it.
you to get ahead and do the next thing,
With that in mind, there's no such thing as a wasted experience.
Put it this way, there could be, but you can try to convert those
Sure.
experiences into lessons learned, right? But you're right, it's not wasted. It doesn't have to be wasted. And if nothing else, you've just learned, that was a dead end. And
Right.
what? It's as important to learn where the dead ends are for you as finding the right path. The message is, don't lose hope. Don't lose
That's
hope and try to find those things that you're good at and how to leverage and get the most out of them.
The glass industry. There's something
Yeah.
about this industry that has, continued to be a sort of like fountain of optimism for the future. What is it about this industry that keeps pulling you back?
One of the things that has struck me is the dramatic changes. Like it's been constant change from my first job, at Columbia Manufacturing, then with advanced glazing, later Alu Glass, and then Artec glazing contractors, and then on even beyond that, into Initech and so on. We started when I started in the 1980s, nobody knew the building code. Nobody read it. Nobody working in the commercial glazing industry had read any of the standards. They didn't know any regulations. They just did stuff they learned on the job. And then they, when a big company went out of business, they'd go and start smaller companies and try to grow them into big companies. But like they all knew how to do stuff, but they didn't really understand the regulatory environment. And the regulatory environment has been in constant change, but it's not just a regulatory environment. So is the technology. When I started in the industry, we didn't use low-E coatings. It was just glass
Right.
and, air, desiccated air inside the glass, right? I didn't learn about low-E coatings until, years later. It seems like there was constantly something new, you're doing one kind of project. Next thing you know, you need to start testing something. Next thing you know, you got to, you develop a new product or whatever, a new regulations coming, energy regulations. So the industry has not been static. Like I would say my whole time in the industry, starting in 1988 till now, has been a time of constant innovation, development, new products, new technologies, new performance expectations, new ways of working and adapting, new kinds of consultants, new kinds of testing and standards. So really, it's been a constantly changing environment. In my case, there was no time to get bored. You know what I mean? Because there was always something new coming around. Now I realize it's not in every career path that you will experience all the novelty. But I think what I have found is variety and opportunity. I guess that's the other thing about the glass industry is, I found it really hard to do project management work. And the reason is because I'm a perfectionist, and the problem is you can't be a project manager and a perfectionist. As a project manager, the details don't count. You got to have the big picture, the focus, the goal, and do whatever it takes on the path to get to where you're going. I just hate doing the wrong thing or cutting corners or compromising, my ideals, and bending the rules when, you should be following them kind of thing. So it just went against my nature. I just didn't have the personality for that. But give me a job to do where I can craft it, or I can write about it, I can design it. I will put all my heart and soul into doing that as well as I can. And so it's just a case of finding where you fit. Some people are really good at those quick decisions, the big picture, bing, 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 bing. And, that's what project management is. That's what you got to have to be a good project manager, So I was just a square peg in a round hole when I was frustrated, but the opportunity in the industry, I found a way to find a place where I could put my skills to work in that industry. And you found a place where you could put your skills to work in that industry. So whether it's sales, whether it's customer service, whether it's innovation, whether it's product design, whether it's optimizing manufacturing workflow, improving quality, accident prevention, safety. I mean, there's endless opportunity. in this industry for any amount of talented people and interested people to put their efforts to. So I think it's an industry with opportunity, and maybe that's what's kept it interesting for both of us.
I would certainly agree. And also, like you said, as you started off there, with how much things are changing, right? And how exciting that is. Like there's, never a dull moment, right? There's always, we have a new system using vacuum insulated glass.
Yeah.
Right.
There you go.
How cool is vacuum insulated glass?
Yeah.
This stuff is amazing, right? Instead of having, your standard, triple with 13 mil airspaces, you have a 16 mil airspace, and then you have a 1/4 millimeter airspace between two of the lights, and you suck out all the air of them, and you have a 50% increase in center of glass from a thinner unit. So the unit is 34 mils instead of 44 mils, and it's R15 instead of R10 center of glass.
Yeah.
Like crazy fun. And so, this keeps us on our toes to see how we can adapt it as a framing manufacturer. And so that it's constantly moving, I think is super exciting. And I think that's actually a good segue to chat about what you had also touched on earlier, was the new National Building Code changes for 2020, which are another example of how things keep changing. Things are not standing still on the regulatory side either. And maybe I might sort of ask if you could sort of set the stage for how did we get to be where we are, when we're considering different materials, sort of different window frames, different sashes, call them what you will, so that some are considered combustible and some are considered non-combustible. When was this decision made? How did we sort of get into this situation in the 2020s? Where did that come from? And then how has it changed recently, and where is it going?
Glad to talk about that. Canada's first building code was published in 1949, I believe. It was a thin little book, about the size of a small hardcover novel, smaller than a church hymn book, But, one of the biggest problems in construction coming out of the 19th century into the 20th century was fire. If you think of a 19th century large building and earlier, you had typically a stone or brick masonry exterior and a wood framed interior. And the whole interior wood frame was highly susceptible to fire. You also had wood windows. Primarily, your main window material was wood. Fire was a huge problem because if a fire started in one of those buildings, as you can imagine, maybe, 5, 6, or 7-story building, a block long, block wide, or half of that, and a fire starts, you've got a lot of combustible material in there. And you have such a blazing fire that's uncontrolled because the fire men cannot put that, if you don't get it out right away, it's out of control. That you could end up where a fire spreads from one building to the block, and from that block to many blocks, to where you actually have burning firebrands in the sky, being lifted up by the hot air coming from the fire, falling firebrands onto other buildings, falling onto windowsills, and causing the wood window frames to catch fire. And then the glass breaks and the wood window frames are burning, the wood inside the building's burning, and it goes on and on. So there were huge fires that would devastate cities. The San Francisco fire, I think Vancouver had a fire that wiped out, a large amount of buildings, early in the century. So fire was one of the main things that they wanted to regulate. And so the building code started classifying materials as combustible and non-combustible. And one of the earliest aims of the building code was to minimize the use of combustible materials. And when you did have combustible materials, to protect them with other non-combustible materials. So you could protect wood with gypsum board, or plaster, to prevent it from burning. The code fairly early on began to look at things as to whether they're combustible or non-combustible. And eventually they adopted a standard that was so rigorous. There are some concrete formulations that if you took a piece of certain concrete and put it into the test chamber for this test, and you heat it with a high intensity, even if it doesn't combust, if it loses mass, if it loses some specified very small amount of mass in that test, it's considered combustible, even though it's concrete. Even though after the test, it's still concrete, and before the test, it was concrete, but it lost some mass, it's combustible under this test. And so that was the test for classifying building materials: combustible, non-combustible. And essentially, the code treated all combustible materials as highly flammable. It's not gasoline, but it's almost as dangerous, right? It's the idea that, you could put a match to that product and the thing will just light ablaze. And it caused people to really worry about some materials, because when a material like polyvinyl chloride is considered a combustible material, but at the same time, how come our fire sprinkler pipes are made out of polyvinyl chloride? Well, it's because it's 50% chlorine, and chlorine is highly fire resistant, and PVC is the most fire-resistant plastic that we have, and it's affordable and economical. And we actually, run our fire suppression systems through PVC pipe. But of course, it's behind other assemblies and so on. But the point is, they're using PVC and not ABS because it is substantially less combustible than other plastics. And yet, to the code, it's as dangerous as balsa wood, as paper, as dry kindling, right? This was the kind of the dichotomy in the code. It just had this classification, and nobody really questioned it. But the assumption was that if it's combustible, it's dangerous and needs to be regulated. What was the regulation? It's reducing the size and the spacing of windows. When I was working for Initech, that was one of the challenges we were trying to face, because in Canada, you couldn't use larger windows in a high-rise building, but we were selling these windows to the United States. We were selling floor-to-ceiling PVC windows for high-rise buildings, high-rise residential buildings in Portland and Seattle and other places with no problems. The products had steel reinforcing inside. They could handle the wind loads. They had phenomenal air and water tightness, super energy performance. You couldn't sell the same product in Canada because it was combustible. I had reached out to some fire consultants. How can we help solve this problem? And the company we dealt with at that time was called Reed Sinez Calder. Three principals. And later it became Serica. One of their staff, Mr. Calder, was a specialist in historical building codes. And we had hired them to help us to do some alternative solution type work. Calder's research showed that, when they started trying to manage high-rise fires, what were their strategies? Their strategies were to make the windows smaller and to make sure that there was a spandrel vertically separating window from window, and horizontally separating them into punched opening windows to limit the fire spread. Less glass area. But when they actually tried to figure out how much separation do we need, it turned out to be about 5 feet. You'd need 5-foot spandrels. And of course, then you wouldn't have enough daylight to light the building for the occupants. So they compromised, and building codes began to introduce spandrels that were about 3 feet from window to window vertically. And then, similar spacing horizontally. And these things were in early fire codes in the US and Canada and other countries. And, when it came to the 1965 building code, which is when the current requirements that were in place until 2020 were, I think, that wording came into the 1965 code. But it had been, that thinking of limiting the spandrel areas had been around since the turn of the 1900s, in the early 20s and 30s and 40s. People were trying to manage it. So they realized if we really wanted to prevent fire, the spandrels would have to be huge. So we're compromising them. They compromised at some numbers that they felt were around 3 feet, and that ended up being embedded in Canada's code. And when we went to metric, it became a meter. So some of these requirements were in American codes as well. I can't say exactly when they disappeared, but at the time I was working for Initech, for example, starting in the early 2000s, there was no such restriction in the United States, but there was in Canada. And Canada, I think, might have been the only country in the world that actually had these spacing requirements. Basically, my point is, it's a relic from a time when the only tools we had to manage fire growth was reducing the size of windows and spacing them farther apart. And all the other improvements we've done to reduce the risk of fire, gyprock to protect wood walls and all these other things that have reduced the fire risk greatly. Somehow nobody ever put 2 and 2 together to say, we're not having citywide conflagrations anymore. We're not having entire buildings go up in smoke with burning embers flying everywhere. The structure of the wood is now steel, it's concrete, it's masonry, it's not wood. What's there to burn? There's finishes, but we've got gyprock, we have flame spread ratings on this and that. Where's the fire risk coming from?
We have sprinklers.
We have sprinklers. Well, yeah. Well, let's put it this way. Even before sprinklers came into the code in 1995, mandatory sprinklering in many occupancies. But you're right. We have done all these other things to reduce the start of the fire. The windows were never the start of the fire, except when we had conflagrations and burning embers falling on large stone windowsills where they could accumulate and set a window on fire. None of those conditions existed anymore, but nobody knew why those things were in the code in the first place. They just assumed there was a good reason and there was a big risk. And because it had been in the code for so long, it must have been a really big risk. It's just that nobody had ever thought of looking at it for decades. That's really what the story was. And I made this clear in the article I wrote for Glass Canada.
Yes.
In
Which
August.
We'll link to
that you'll link to, yes. I've basically given you the history of how this code change actually came to be. But the long and the short of it is that some Quebec manufacturers had done their own fire testing. They had shown the results to the National Research Council, said, why are you regulating our products? They're not performing any differently in a real fire than aluminum products. As soon as you start the fire, the glass breaks and then the flames go inside. The window frames aren't really participating in that. Why are you regulating combustible window frames? So the National Research Council, we're working with Serica, these fire engineers. I think it was Peter Senez of Serica reached out to me to let me know that NRC is looking at potentially encouraging the industry to put a code change forward to eliminate these restrictions. And I arranged a meeting at Windor in 2014 for the NRC folks and the Serica folks to come and talk to our industry, because NRC said, we recognize that the code is out of date in this area. It needs to be changed. If you leave it up to us, we might get around to it, but it could take a long time. We understand that this is a needed code change. And so if the industry will go through the effort of doing some research and putting forward a code change proposal, we encourage you to do that if you want a code change to come sooner, is really what they said. And that's what led to the combustible windows code change process that is described in the article. I just want people to know that the NRC recognized this was an overdue change, that it needed to be done. And that's why the industry did the research. The purpose of this code restriction was to minimize the risk of vertical fire growth. It wasn't to prevent a window frame from burning. The window frame could be burned and disintegrate, doesn't matter. Mm-hmm. But does it contribute to the spread of fire? Does fire spread faster if you have a combustible window frame than if you have an aluminum window frame? And the answer was no. And really, so why do we have this code change? So it's as simple as that. And I mean, it took a lot of work to, convince the authorities to do the research, to show and to demonstrate and to test different windows and materials, under identical conditions to validate that point. The point was made and the code change was adopted. It's about time, let's put it that way. I guess where I was helpful in this process is because I'm a good writer, a good communicator, I was able to draft the code change. The industry consortium hired me to be their representative. So I was their interface with the researchers. We discussed the test program together and so on. All the big decisions were made by the industry consortium, but I was their representative and the communicator, and worked closely with NRC on the final report. It was great to be a part of that project, and my previous experience in writing, communicating, advocating for the industry, all kind of played into being able to serve that role in this project. So it was a very satisfying project for me. Of all the things I've done in this industry, that is the most significant and the most sort of long-lasting effect. To be able to be a part of that process and to bring that process code change to a conclusion was something I'm personally proud of and very satisfied with. So,
and you absolutely should be, Al. And we on behalf of all of us, who are using non-aluminum framed sort of window and curtain wall systems, we thank you, hugely for your efforts. It means a lot to us. I mean, we've maintained our CANUL CS134 certification for all of those other sort of areas where even with the new code change, there's still need for the non-combustible certification. But there may come a day when we are treated with the equal sort of consideration, respect, understanding for safety that aluminum and steel systems are as well.
Yeah, and this is where the one concern that some people had on the standing committee, and I must say this concern did not come from the standing committee itself. In other words, none of the fire science kind of guys were concerned about this, but some of the engineering firms in Canada, one in particular, had indicated they didn't want to see this code change apply to a curtain wall condition. They didn't want there to be a continuous framing system of non-combustible material. And I think this was just out of an excess of caution. Well, we haven't actually tested that. Fundamentally, we had, because except that there were, they were non-combustible floor slab sort of spandrels in the test assembly. So technically, we didn't test a contiguous assembly. We had to concede that change by saying there's no restriction on size, but it can't be a contiguous system. And this, I think, was a very conservative concern. I don't think it's grounded in, I don't think there's any evidence that there is a risk, but clearly some people felt that it was too soon to greenlight contiguous systems. So essentially, that's the one restriction that remains in it, which unfortunately affects curtain wall in your case. And that's why, for curtain wall, you probably will need that ULC certification to allay that concern that some people had about this code change. But, I just want people to know that it had gone through the standing committee for public review without that. You know what I mean? So this was feedback from some architects and engineers who didn't understand how we got to this point, but it just felt to them like it's just a bridge too far. We're not quite ready to go.
That's funny.
And so it's that kind of caution that put that restriction in. It was not based on science. It was based on fear.
Caution. Which is fascinating that caution is also based on, what we've been taught for the last 50 years.
Exactly. Yeah.
Not based on, as you said, any of the research. That's fascinating. And so, maybe sort of segueing, in what sort of areas can different municipalities or different provinces, sort of differ from the energy code or the fire code?
That's a really good question. There's a really
parts
good
of the
question.
code. Because we've seen with the BC Energy Step Code, you can go ahead, with your energy performance here. Can you go ahead with air and water tightness? Can you make that more stringent? Presumably, the National Building Code makes a sort of floor that no province or jurisdiction in Canada can go beneath that. But can any jurisdiction or any, sort of municipality, sort of say, we want even more stringent fire codes. We want even more stringent energy, water, air, blast, certifications. What are the parameters that are, is there sort of like local autonomy on?
It's a really good question, and it's something that's maybe not as well understood as it could be. The thing to remember is that in Canada, the provinces have a lot of autonomy, and construction is a provincial responsibility. So the regulation of construction is a provincial jurisdiction. The federal government has no role over that. So the federal government, the National Research Council, puts out a model code. It's called a model code because it represents, shall we say, our best efforts using science and sound judgment in building construction to be up to date in terms of managing safety risks, environmental risks, and the durability of buildings and increasing the energy performance of buildings. So the national code is a model code, and it doesn't take any effect anywhere except, I believe, on federally owned properties. So I believe the National Building Code would apply to a federal building in a province, that was being designed or rehabilitated, by the government. But apart from that, construction is a provincial responsibility where the provincial building code prevails. But in the last, let's say, 5 to 8 years, it's been identified that the variations in building codes from province to province hampers business efficiency, because there's a lot of trades that cross provincial lines. Installing windows, in BC or installing windows in Alberta. Yes, there are differences, but essentially, are the differences so great that you should have completely different rules for something like that, or for qualifying them, or for testing them, right? And that's just for our window industry, but it goes for everything. So there was a process where the federal government and the provinces looked at this question. They came to an agreement that the more provincial codes are disparate from one another, it makes it harder for businesses to compete cross-provincially, which drives up the cost of construction. And so in order to make building construction more efficient and more affordable, it is desirable to minimize changes. between the national code and provincial codes. And so several years ago, the provinces and territories at a high level sat down and signed an agreement with the feds that they were going to harmonize their codes as much as possible in a very short time frame. So the next code, the 2025 code, the provinces are re-examining they've already started in the 2020 code to some extent, but that's going to be essentially, that process should be, I think, essentially complete, if I'm not mistaken, for the 2025 code. So I know that BC is now looking to harmonize in many areas where it has differed with the national code on energy, on other matters where it differed. On the other hand, the provinces may also want, in some cases, if they feel their code language is better than the national, to try and get the national to change, to adopt something they've done. But essentially, they've all made a commitment to harmonize within 24 months of the signing of that commitment, and they're underway to do that now. So you are going to see less of that. When the 2025 code comes out, it will be substantially harmonized across Canada.
I'm just wondering, is that relate in any way to what's happening right now with this Bill 23 thing in Ontario? Like, is the logic there where there's, it seems to be a sort of watering down of the energy performance standards of the Toronto Green Standard in favor of, again, like you said, more efficiency, more cost effectiveness. Are those conversations related, even though they're slightly different sort of jurisdictional levels?
I think what's going on with the Toronto Green Standard, I think that's more of a provincial matter. It's not an area that I'm closely acquainted with, but from what I've read, it seems to be the provincial government's initiative to do that for their own reasons. And the Toronto Green Standard was never it wasn't the national building code either, right? This was basically a local regulation aiming to go beyond the code. And I think it's provincial pressure. It's the province's agenda that is affecting the Toronto Green Standard, not the federal agenda to broadly harmonize codes across Canada. In the past year or two, I have not been following the national issues as closely. That might be ironic in my role at Fenestration Canada, but I'm more focused at Fenestration Canada now on the residential sort of sector. I have not been monitoring what's going on things that affect the commercial sector, for the last couple of years. So my attention is focused more on what most Fenestration Canada members are doing. Now, there's a number of Fenestration Canada members supplying windows to high-rise buildings, but these are generally not the commercial fabricators. They're not commercial curtain wall products and things like that.
With regards to your current role at Fenestration Canada, maybe we'll wrap up on that note. What are you currently working on, and what are you hoping to see for this next generation?
At this point in my career, I'm cutting back in terms of the hours I'm working. And so what I've focused on, let's say the second half of this year, I've been looking at the comfort issues related to glass, thermal comfort issues. We've spoken so much about energy performance, U factor, solar heat gain coefficient, energy rating. That's been the whole discussion. We are seeing that if we're not careful, certain kinds of glass can make people very uncomfortable. We're building homes and with larger and larger glass areas, and we're not sufficiently articulate about how do you choose the right glass. A high solar gain glass might be fine in a 1970s, 1980s, 1990s home with a fairly low window to wall ratio and without really huge windows facing any one direction. Having a moderate amount of solar heat gain, even a high amount of solar heat gain distributed over windows that it might get sun, might not get sun, some they do, but you're not likely to lead to huge overheating problems. In British Columbia, there's been pushback to high solar gain windows because our homes tend to have larger glass areas because of our milder climate. And all of a sudden, when your living room window is, 5 feet high, 7 feet wide, flanked by two operators, and if that's getting, any significant amount of sun and it's a high solar gain glass, you'll have an oven. We haven't had a good way of choosing glass. And because we talk about energy metrics, we don't have any comfort metrics. So what I've been focusing on is, when you use the window program to generate your energy properties, your U factor, solar heat gain, and all that, that program generates other data as well. it generates winter and summer glass surface temperatures. Now, that's important because if you have large windows and you have a glass option that gives you a colder glass surface temperature, you might have a good U factor, and it might be energy efficient to the point that it's perfectly compatible with the code. But when it's a 7x7 window, in a smaller room, that colder glass surface temperature will be very uncomfortable. It may lead to drafts, and even just the radiant asymmetry between a warm wall and a colder glass window temperature will be very uncomfortable. There's cold discomfort. On the other hand, if you have a high solar gain glass with that large window, you're going to have a huge amount of heat coming in. But how much heat? How do I know where to draw the line? Like, how do I make a decision about what glass in what area? I've taken a look at data, and every manufacturer that has a product line, when you look at their energy listings, there's like thousands of rows of data for every glass option you sell in every glass airspace thickness, every glass thickness, every product configuration. You've got data, you don't know what to do with, but we can't see the forest for the trees. In terms of what in this data helps me make a decision about what glass I should use. So I've focused just on the glass. I've taken that NFRC data, but not just the energy performance characteristics. I've taken the glass surface temperature data and a metric called the relative heat gain. And the relative heat gain is a worst case solar heat gain condition. The sun setting in the west at a normal, at 90 degrees to the surface of the glass, the full intensity of the sun coming through. That's what your relative heat gain is giving you. And it's in watts per square meter. You can multiply watts per square meter by the area of a window to find out how many watts come through it per hour. And you might be surprised to know that, let's say, a standard patio door at the NFRC size, 2 meters wide, 2 meters high, has about 3 square meters of glass. And if you have a double pane high solar gain glass in that door, you will have close to 500 watts per square meter of heat. Now, this would be in a west-facing condition, right? Your worst case scenario, clear sky, full sun, but 500 watts per square meter times 3 meters is 1,500 watts. That's a space heater, right?
Yeah.
So the thing about the relative heat gain that's helpful is, yes, that's a worst case scenario, but it helps you to compare products, and it helps you to get an idea of how that size matters. Small window, no big deal. A large patio door with flanking fixed window side lights, because you have a west-facing view property, and you want some high solar heat gain because of all that glass to keep you warmer in winter. Well, you might just have, thousands, several thousand watts, on that west-facing window, the heat buildup coming in through all that glass. Now you have more information than just a solar heat gain coefficient, right? Now you get a sense that, wow, if it was a small window, no problem, but I've got too much glass here for that. So glass surface temperatures, relative heat gain. And when you look at the low E coatings, we obsess over a single silver, double, triple silver. There's a difference in the U factor, and it's a second decimal place difference, and it helps me to meet a code requirement. But when you zoom out, when you round your U factors to just 1 decimal place instead of 2, there's not much difference between single, double, triple silver. And if you look at the R value, the inch pound R value, if they're double glazed with one low E coating, doesn't matter what coating it is, it's an R4. If you add a second low E coating, like on this indoor surface, 4th surface coating, it's an R5. Triple glazed unit with 1 low E coating in it, R6. Mm-hmm. A triple glazed unit with 2 low E coatings, doesn't matter which ones they are, it's going to be R8. And 1 more room side coating, it's R9. So within each group, the differences in low E coatings in terms of heat loss are not significant. But you look at the solar heat gain numbers, you look at the relative heat gain numbers, big difference. You look at the glass surface temperatures. Those room-facing coatings cool down the glass and potentially could lead to drafts and things like that, right? So with the glass temperature data, with the relative heat gain numbers, and just looking at glass from 10,000 feet, in one table, there's enough information to guide intelligent decision-making on what kind of glass you'd want to consider with respect to orientation, external shading, and glass size. You've got an ability to have a conversation with a customer, with a homeowner, with an architect about why you should think about this kind of glass versus that. Here's your worst case solar heat gain with the high solar product. could be 400 watts per meter. Look at a low solar product, 200. If you're an all glass building, which one do you want? Even 200 might be too much. Maybe you need to go with an extra low solar glass in that case, right? So this is what I've been focusing on. I've written a paper to present the thinking behind this approach. I've presented to the Fenestration Canada Technical Services Committee. I've given several presentations on it, one at Windor, one at the BC chapter meeting of Fenestration Canada last spring. Just this month, I've given 3 presentations at the invitation of BC Hydro to two of their project teams and one to the Building Research Committee. So I'm looking for feedback on that paper, and I'd be happy to share it with anyone that's interested in it. I could provide it to you if you want to let people download it. It's giving us a new way of looking at these numbers. And recently I've been in discussion with an engineer in the United States. And with his help, we're going to be able to take the approach I've recommended. These numbers are generated under NFRC conditions, right? Minus 18 outdoors, plus 22 indoors for winter, and the NFRC summer conditions. But it's very easy to translate those numbers for any temperature differential. So we can take this approach now, and in the next version, we're going to be able to say, well, in the Vancouver climate, what's your temperature differential indoor to outdoor? Here's where your glass surface temperature will be. Here's where your relative heat gain number will be. So we'll be able to make it even more useful for decision making, is what I'm trying to say. So that's what's got me excited. And that's what I've been working on primarily in the last 6 months at Fenestration Canada. Something I'll be continuing to work on in the future to take it to the next step, to provide really practical, useful guidance on selecting glass with the comfort of occupants in mind.
I think you've provided really practical, useful guidance on a few areas for us today, Al. It's so easy for all of us to get sort of wrapped up into these spreadsheets, but one thing, we certainly like to talk about, and certainly my lunch and learn presentations, that, do we design buildings for spreadsheets or do we design buildings for people? We forget sometimes that we do actually design buildings for people, and we don't design them for spreadsheets. And thermal comfort is such an important one. Certainly something that fiberglass sort of offers in lieu of aluminum. But I think also what you touched on with different climate zones as well is incredibly important, because I've heard sort of through the grapevine some of the challenges, especially in the BC climate, of trying to incorporate this European passive house system into the sort of warmer coastal environment, and that overheating can be an issue. And when we're not factoring in all of the the typical sort of geographical particularities that make each place on this planet unique. We tried doing these universal, the international style of architecture, and sort of plonking the exact same building everywhere in the world. And yeah, it doesn't always work quite the way we imagine it would. But it's exciting to see that there's more and more development, growth, and an opportunity in trying to find the forest for the trees. On that note, well, thank you very much for joining us for Curtain Wall Conversations. It's been an absolute pleasure, Al. Where can people find you online going forward, and how can people reach out?
Well, I'm on LinkedIn. You could find me there. I think maybe I'll put the thermal comfort paper onto my LinkedIn, to make it easier for anyone who wants to see that paper to do so. But that's probably the easiest way to get a hold of me, as you did through LinkedIn.
We'll put up a link to that in the notes as well, so people can reach out to sort of continue the conversation, and if they have any other particular questions for you. But thanks very much, Al. It's been an absolute pleasure.
Thank you. It's been a real pleasure to speak with you too, Peter. I appreciate the pioneering work you and your company have done to promote fiberglass as a viable curtain wall material, because it has really compelling properties for energy and comfort, as does PVC. And each material has its strengths, and certainly fiberglass has very compelling properties, especially for curtain wall. So I don't think we'll see PVC curtain wall anytime soon. Let's put it that way. But still, great for the work you're doing. Honestly, see, this is it just never ends in our industry, right? We have so many challenges to face. We haven't even really begun to adequately address some of the challenges like climate and sustainability to the degree that we should. So I think we'll all have our hands full for a lifetime. So
We hope you enjoyed this conversation as much as we did. Be sure to follow us on LinkedIn, Instagram, Twitter, and Facebook to stay up to date on new episodes of this series. Also be sure to check out our Spotify and Apple Podcast accounts, where this episode and others are now available. If you have any questions about our conversation today or fiberglass framed curtain walls in general, feel free to reach out to us via email at info@glasscurtain.ca. You can also subscribe to our blog for all the latest updates, which we'll link to in the description below. Thanks very much. We'll see you next time.